For those of just joining and are coming on right now, I'm really excited to be here, and I totally understand and respect being a student. I'm still a student of SANS, and I've been a student of SANS for 18 years. What that means is that learning never stops. So I was on the IT side way back in my early part of my career, and now in the industrial control system side for a very long time now. So let's get into quick introductions. My name is Dean Parsons, as Ashley mentioned. Really excited to be here. And I am a principal instructor with SANS. I teach two main classes. One is a very technical, hands-on 5-day class, ICS 515. So it's visibility into the control system environments across all sectors in ICS and OT. It's also threat detection and industrial incident response, we like to call it. I'm also a co-author, and I teach another class, which is the 418 class, so the ICS Security Essentials for Leaders. So it's a leadership level class, 2-day class to understand how to support and realize the risk in industrial control systems, how to manage that risk appropriately as well, building teams and making sure those teams have the right skill sets and the technologies to do ICS specific incident response and so on. So as I mentioned, roughly around 20, wow, going on 22 years-ish experience in cybersecurity and defense. I started my career in IT, and so I know there's going to be questions today. Please drop them in the chat about how do I transition from IT to ICS? How does that look? What's the first few steps to get there? I made that transition from IT in telecommunications. So I was a lead incident responder. I was hiring people. I was doing the hands-on, and I still do lots of hands-on tactical work, but I focused on IT and telecommunications, and then started building teams and policies, procedures early in my career in telecommunications. And then I transitioned from IT into industrial controls, or IT, or sorry, OT systems. I did that into the power industry, into power generation, transmission, distribution. And in that role, I again hired more people. I was the lead incident responder doing all the ransomware incidents and targeted attacks, and also getting to all of the facilities, of course, inside the power system. Held roles there as also the CISO of overall security for IT and ICS and OT. Then I transitioned from the energy side in electric power to oil and gas, refineries, marine terminals, storage facilities, distribution, fuel distribution facilities, and so on. What that means is this: I'm trying to bring as much experience to this conversation as I can within the 55 minutes that we have. So between my teaching with SANS 515, 418, I'm in the field. I'm doing assessments, I'm doing cybersecurity threat hunts, penetration tests, and so on and so forth, which means when I'm not in the class, I'm in the field, meeting with the people in the engineering side, in the IT side. And then I get to bring those experiences into the class the next week or the following week, etc. So today's topic of conversation is industrial control systems, defending what makes, moves, and powers our world. And when I say those words, we're really thinking about these kinds of industrial environments: transportation, marine or otherwise, gas, fuel distribution facilities, oil and gas refineries that, creates the fuels that we put in cars and jets and vehicles, and etc. Chemical manufacturing, healthcare, water systems, building automation control systems, heavy manufacturing, and so on. So what we're about to have a conversation on stretches across all of these sectors. And we're going to leave today with the understanding of 5 critical controls that actually apply to every one of these sectors here. There's a lot of controls out there. As I understand, a lot of you folks come from the IT realm, and there's hundreds of controls we can put on devices and mitigating controls, and that's wonderful. From the ICS perspective, there are lots of controls as well. We're going to focus on 5 of those controls, and they're prioritized controls. We're going to understand through our case studies today that these top 5 are critical. We have to first start off with the differences between IT and ICS. And as I'm getting started here, just want to remind everybody, if you have questions, please drop those in the chat. We're going to address any questions that you have in the Q&A, or if there's a burning question right now that you have, let us talk about it. And Ashley and I, we can kind of bring it up and go forward. So the main thing here is that understand and embrace the differences between industrial control systems, or OT, and IT. The basic difference here is this: IT's been doing amazing things for decades on protecting data at rest, data in transit or data in motion, and data in use. Fantastic. And we don't want to change any of that. They're experts in that. On the other side of the slide here, on the right-hand side, this is where we talk about the ICS or OT. This is not necessarily data protection. This is protecting physics. This is kinetic components, changes in the physical world as a result of an engineering decision. So on the right-hand side of the screen, that's where OT and ICS live. Now, to understand a little bit more about this, I want to show you some imagery of industrial control systems. And I want you, in the back of your mind, I want you to think, how can a traditional operating system, Windows, Linux, fit into this environment, or does it at all? So let's take a look at what an industrial control system actually does generally. It will monitor not necessarily for data, but it will monitor physics, which means it's monitoring things like temperature. So it has different, for example, in a steel facility, a blast furnace to make certain metals. The temperature inside of those blast furnaces are going to be things like that are going to be sensed in the environment and captured, and then decisions will be made based on temperature calibration. But also, if we go to oil and gas as a sector, that how much pressure is needed to push oil and gas through a pipeline, for example. So temperature, pressure is being monitored on a regular basis. And based on the temperature, pressure, and even the level of a certain volume of chemical or fluid, for example, the physics kicks in and makes a decision based on, is it a good decision to have this much level of fluid or this much pressure or temperature, and so on, even the flow rate. So quickly, we're starting to see now that there is data inside of ICS environments, but it's not just let's protect the data. It's we need to protect in the ICS and OT the devices that sense the real world and make changes in the real world. Anything from sensors to control valves to pumps to heaters, furnaces, boilers, and so on and so forth. So we're already starting to see a difference now between IT and ICS. So if we were to walk into a business building today in an IT environment doing awesome things, we would walk in and we would see computer systems, people with business attire on, etc., which is fantastic. Inside the ICS environments, if you go to the field, we all leave today together and do a field trip, and we go to the field, we were going to see things possibly like this. So in oil and gas, midstream, upstream, downstream, you would see devices or tanks, we'll call it, for storing fuel or storing different types of liquids or refined or non-refined products for oil and gas, pipelines to get them the product where they need to go, refineries to refine them, and so on and so forth. And on the bottom left-hand corner, this is the heart and brain of any control system. This is a programmable logic controller. Now, I mentioned earlier, where do you see Windows and Linux fit into these environments? They're there, and they're definitely helpful to have in these environments, for sure. But the brains of the operation really are driven from that PLC, programmable logic controller, in the bottom left-hand side of the screen. So what about if we switch now from the ICS in oil and gas over to the electric power sector? Again, this is exactly the kinds of environments here that generate our power and that transfer our power to large geographic dispersed transmission lines and into our homes and so forth. And on the top right-hand side of the screen is another pivotal engineering asset. This case here, it's called a protection relay. So I'm trying to again look at the differences between IT and ICS here. And while we will have and see some Windows environments and some Windows assets that we traditionally see in IT, like you see in the middle of the screen here, these are called the HMIs. So Windows exists in some of these environments, but by and large, as an example, in water, we have also piping, we have instrumentation, we have large pools of water that's cleaned and cleansed and distributed back to homes once it's refined and so on. So in this case, we are seeing the differences between IT and ICS. But now I want to take that idea that they are different and I want to embrace those differences. And I want to think about, if we all right now went into a control system environment, what would we do to control or monitor or protect that environment? What controls would we deploy to protect all of those images we see here in the pumps and all of these things? If we take a look on screen now, we know that if you copy what works in IT and you paste it, for lack of better words, paste it into an industrial control environment, we know that there's going to be problems with that because the controls are not built for the control system. And in many cases, as you see on screen, if we look at antivirus, we know how that operates in IT. Don't change it for IT. But if we take it and put it into the ICS, there's a different way to utilize it, and so on and so forth, as you see here. So the environments are different, the purpose of the environments are different. Protect data versus protect and ensure physics. So the controls are also different because of those reasons. Even things like at the bottom of the screen, patching and network detection and intrusion detection are different inside of control systems. And it just so happens patching and network intrusion detection systems, those are two of the five controls we definitely heavily recommend for ICS. But as you know here, they are ICS specific. And mostly the reason is this. In IT, for a long time, we've been focusing on confidentiality, integrity, and availability. Fantastic. That's the pillar of IT security. Inside of ICS, there's a misconception that it's not CIA, it's AIC. It's the reverse of that. That's not quite accurate either. On the right-hand side of the screen, this is how we prioritize things in control systems. Safety first above everything, then industrial control system, integrity of the assets, availability of the assets, and then confidentiality of the data that it supports or senses in the environment. So just based on this slide alone and looking at the differences between hardware devices and environments we just looked at and Windows and Linux environments, we now know that the mission is different and that dictates different types of controls and how to use them. But don't take my word for it. Look at DHS. They say absolutely, quote, incident response as one example, deployed in IT business systems may result in ineffective, even disastrous results when applied to ICS cyber incidents. So again, even the processes are different. So here's the thing. We're talking about the differences between IT and ICS. I think we nailed it. Let's get into why we actually need to have controls for ICS. So I'm reminded again, if you have questions, please drop those in the chat. So have we seen incidents in the last 5 years, 10 years, 2 months, 3 days in control systems? The answer is yes, 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 and yes. We're seeing definitely more targeting towards industrial control systems. And what I've done here in this next section is just take a small handful of the types of threats we've seen in control systems. It just so happens that usually in a control system, when there's an incident, the impact is far larger and more impactful and impacts safety than what we'd see outside of control systems in other environments like traditional environments. So on the screen, we will see a number of different threats. Again, these are only a handful. I'm going to specifically focus on the PIPEDREAM malware as we go through the next couple of slides. And I'll talk to you as well about the Ukraine attacks in 2015 and 2016. So as we go through, let's take a first look at the attack in Ukraine. Now, you may not know, and if you do, that's awesome. And this goes back a decade, in this case, a decade ago, the Ukraine power grid, one of the Ukraine power grids were attacked. And the adversary had a specific way to target this environment. And the entire conversation of this use case can go on for days here. I'll keep it to like 30 seconds or a minute, but here goes. A power system was targeted in Ukraine, and the adversary did not use malware to cause the power outage. They used malware in this case to get access to the environment, and as a result of getting access to the environment, they gravitated towards Windows environments that run what we call human machine interfaces. It gives them the ability and our engineering staff to disconnect, energize, or de energize power to a region, a city block, or a city. And as a result of this targeted attack on the electric facilities in the distribution level, in this case here, the adversary went on those HMIs and literally clicked on disconnect breakers in many cases. Now that's oversimplifying, but generally that's the idea. So the adversary focused on getting access like an operator would, and they used that power and authority against the control system to cause power outages across Ukraine, leaving 225,000 people in the dark. And there was a lot more happening just than this, and it was definitely an advanced persistent threat actor who was actually in the environment up to 6 months prior to the attack, building the attack, testing, positioning. So this was not some like script kiddie in a basement someplace. This was definitely advanced for several reasons. So let's take a quick walk through the attack, remembering in this case here the differences between IT and ICS. As you can start seeing here, the attacker was on the internet, focusing on targeting the industrial control systems way deep down in the organization. So the adversary started on the internet and pivoted from the internet into traditional environments, IT environments, through, you guessed it, we all know and love, we actually hate it, but we all know and love, email servers. They land on the IT network. As a result of this, they're nowhere near, shouldn't be, anywhere near the ICS, anywhere near the systems that control power distribution, power generation, power enablement at all. But they continued further in this organization from the email servers, continued down through business workstations. And then from there, they targeted directory services or Active Directory authentication services, for example, gathering credentials, valid known credentials in the environment to obtain remote access. They then continue to do additional, I'll say, reconnaissance in the environment to understand what devices existed, what devices had access to what you see on the screen. Number six, across the board, operator HMI has access to and the ability to control in the field devices. So with access now in the control system environment, after pivoting from the IT network into the control system, they had access just like our operators would at your local substation, the ability to energize power, de-energize power. And as a result of that, they use that capability then to position themselves to cause blackouts, but they also continued additional efforts to make recovery very difficult for the operators and engineers by wiping out traditional Windows operating systems. Now you might think, wait a second, if they wiped out the Windows operating system, how did the engineers in the Ukraine utilities get back up and running? So it turns out this entire attack, the from start to finish, beginning of the attack started, it was roughly about 3 to 6 hours of a power outage in Ukraine for 225,000 customers, like we talked about. So how did they recover really quickly if they planted kill disk malware to take out the traditional operating systems? So after this attack, they started recovering roughly 6 hours after the attack started, and they continued to operate for 11 months in manual mode without those traditional Windows operating systems. So again, recap what we've seen here, IT, ICS are different. The pattern we're seeing now, even 10 years ago and now, just as you see here, following down through one, two, three, four, up to six, the IT network is a pivotal area where adversaries can commonly target and work their way through IT into the control system. Now, I don't want to get too heavy into the math or statistics here, but in this case, 46% as of today, 46% of threats that target or that compromise a control system, those come from the IT network, just like this one did. So the engineers started recovering 6 hours after the initial attack, and as a result of that, they worked in, well, we'll call it manual mode for it was almost 11, almost 12 months until another attack happened. Now we're pivoting towards another ICS specific attack. This one here is also on the electric power system. However, this one is a far different technique, a far different type of attack, and it caused more power outage, also targeting Ukraine. So one common note here is that there is geopolitical tensions even today in 2025, obviously between Ukraine and Russia. This geopolitical tension is a conflict that's been going on for a very long time. What we're seeing in this example and the Ukraine 2015 example is that those cyber aspects are another component of a longer term conflict that's been going on for a long time. So if we pivot now from the previous slides from 2015 attack into the 2016 attack, this is the crash override framework, an attack specifically targeting the electric power transmission level substations in Ukraine. What that means is this. It means 3 times more power outage. Now, in this case, this is a very different type of targeted attack for ICS because the Ukraine attack in 2015, again, I'm simplifying, it was getting on those traditional Windows operating system and clicking on open breaker commands to enable PLCs in the field to receive that command and say, oh, you want me to disconnect power? And it disconnects power. In this case, it was not like that. This is a bit of a framework in this case. Crash Override was designed to inject into the network the appropriate engineering protocols, abusing the native engineering protocols to communicate directly to field devices to have a similar impact of opening breakers at a transmission, larger substation, larger power outage. So we've covered Ukraine attack 2015 at a high level, crash override. Now we're starting to see the ability of living off the land for industrial control systems. And this is back in 2016. Now, what I want to talk to you about before we get into the top 5 ICS critical controls is something we call PIPEDREAM. has a couple other names as well, but we call this as PIPEDREAM. PIPEDREAM today is the quintessential cyber attack tool, Swiss Army knife, unfortunately for adversaries. This PipeDream malware is a dedicated piece of ICS malware that is scalable. It's scalable not only across electric power systems like we just covered, but oil and gas, manufacturing, chemical manufacturing, water, wastewater, and so on and so forth. Oil and gas facilities as well. So PipeDream is that essential scalable framework that has the capability to cause disruption, degradation of an industrial control system, and possibly even physical damage. Now, what's interesting about PipeDream is that we were fortunate enough to discover PipeDream on US soil before the adversary actually executed it. So they definitely had the intent, no question, to cause degradation, disruption, possibly physical destruction of devices. In this case, they initially targeted electric sector and oil and gas. But it's important to know here that PipeDream is scalable across those other sectors as well. Now, this is not all doom and gloom. Believe me on this one. I'm in the field between my teachers, as I mentioned. I'm doing incident response. So I'm understanding how there was a compromise. I'm also understanding how we get back up and running and recover. So through all that experience and through the analysis and through threat intelligence that we all receive, we definitely know that ICS defense is not only doable, in many cases, it's actually easier than ICS. So as you can tell here, PipeDream, we know about it. We know a little bit about it. We understand its potential that it can cause and the consequences it can cause. But 40% of the techniques that the adversary uses, 40% of those is detectable. 80% of the tactics that this adversary uses also detectable. So yes, this is an advanced persistent threat. Yes, this can cause physical damage. And yeah, totally, we can discover this well before it's positioned. And that's what happened. We were able to discover this before it was executed. So what do we need in a control system environment? What do we deploy to protect our drinking water, our power for our cities, homes, hospitals, etc.? There's a number of controls. And you guys know from your studies, from class, from your industry experience, the controls for IT, which is epic. What we've done here in the SANS ICS team, driven by Rob and Tim in the SANS ICS team, they've developed the SANS 5 ICS cybersecurity critical controls. What I want to do is I want to walk through each of these controls. And you might think, wait a second, incident response is the first control. We do that in IT all the time. And you're right, but there's a nuance to every one of these controls. So what Tim and Rob has done is create these 5 controls based on the threats that are out there and evolving as well. Of all the controls you can think about putting inside of a control system or in IT, these are the ones that are prioritized based on what the adversaries have been seen to do again and again and again. If an organization in ICS OT have these in place, they drastically, rapidly reduce their risk. Let me put it another way. So protecting our critical infrastructure, the things that move, make, and power our world, if a utility does not have these in place, at least, they're at high risk. So what I want to do is go through each of these, talk about the nuances between them, and again, I'm reminding folks, drop any questions that you have in the chat, and we'll get to those shortly. Okay, so the first one we're going to talk about is the ICS specific incident response plan. Now, we know from IT that an incident response plan is a document that's exercised. We have people that's assigned roles and tasks on each part of the plan. So take that idea and let's go into that from an ICS perspective. The first thing here is determining what scenarios pose the most risk to an industrial control environment. In IT, the most risk is possibly ransomware, taking all data down, all systems down, possibly having a ransom payment that's lurking, etc. Downtime, brand tarnish, exfiltration of data, financial loss, not a good day. So number one here is from an ICS OT perspective, what causes or what scenario poses the most risk? Usually it's not ransomware. Now, let me be clear, ransomware is not good to have anywhere. But in this case, safety impacts are huge. It's the most important thing to preserve in control system environments, the safety of human beings, the safety of the environment. And these environments, if mistreated, misabused, or mismanaged, can cause safety problems. And that's why everyone in the ICS always wear protective equipment. Hard hats, visible vests, ear protection, foot protection, and so on and so forth. So, what scenario poses the most risk inside of a control system? Anything that impacts safety. Remember, we're talking about physics. Number two here is consider the consequence-based scenarios, as in, can people die as a result of this? I don't want to get too far off the rails because I can definitely spend more time talking about this. We've seen targeted attacks on safety systems as well to take out safety capabilities that protect people. So it's really driven from the perspective of safety. And number three is, okay, now we have a scenario. We prioritize safety, an impact that takes down engineering devices, maybe physically damages them, that can impact someone's, can cause injury, for example, from someone in sight. Then is to perform the tabletop of that. And that's wonderful. I love how we get through one and two and three is now we just got to do a tabletop. What's pivotal here in an ICS specific plan is the people at the table. If it's just IT, why are you doing a tabletop? In this particular tabletop, we need to have engineering staff that drive and lead that scenario. They know the control systems. In fact, 70% of the control systems are not running traditional operating systems. So engineers sit at the table and they're running the show. Also, IT is there as well. For sure, we need those expertise as well. Safety is also sitting at the table and so on. So we will generally use the same type of quote labels or steps: preparation, identification, containment, eradication, and recovery, just like we do in IT, but every single step here is different as a result of the different systems. So that's generally the idea. And when we're talking about these traditional steps of incident response, definitely want to remind people here, because of the 70 or 80% of the control system being non-traditional operating systems, not running Windows or Linux, we must prioritize the engineering recovery. Recovery in this case is not just re-imaging a Windows box. This is set points, data tables, configuration of engineering field devices, and so on and so on. The recovery here is not the same. So again, it's a different nuance approach to each one of these steps. Because of the threats we're seeing, such as PIPEDREAM, which we covered, it has capabilities to cause physical damage, then the idea here is to prepare for damage at scale. So incident response plans for ICS include those safety teams, the engineering teams you talked about. And the reason I held a little bit on there for recovery is that the recovery of these assets are important, so much so that we could likely see, will likely see, physical damage as a result of a cyber attack. So preparing for the recovery of those kinds of events likely going to happen, then that's really the engineering side of the house, dealing with and working with IT during an incident, fighting through the attack. So as we mentioned here, recovery in these kinds of scale events, or even ransomware events, it's not just the operating system. As you see here, there's programmable logic controllers, embedded human-machine interfaces to operate the process from a touch panel. There's smart valves that have firmware configuration. They have what we'll call variables and tags that should be defined, for example, before the system starts up, and different states of the system. So there's more to it than just let's run an incident response, let's get malware from a Windows box, let's do analysis, let's recover. That's only about 20%, maybe 30% of the industrial control system incident response. So now we've definitely defined the differences, and there's a reason why. Getting into the next control, and again, got any questions? Let's build on those questions in a little bit as we kind of move through. The second control is defensible architecture. Now, IT does this really, really well. IT has users on a couple of segments in their network segmented off. They also have the servers in the IT network segmented off. They have an external point of presence, such as a DMZ and then the internet. Fantastic. Inside the ICS, let's get into the details here. Traditionally, we've been doing very, very good on sectioning out, protecting the control system from networks like the IT network and the internet. However, we can learn a thing or two here from IT, because at this perimeter here, that big blue block on the bottom portion of the screen, that's the industrial control system. If you look at this entire slide, from the top yellow portion, the middle green portion, and the bottom blue or purple portion, that represents your entire organization, if an organization is in ICS. So that means that the blue section here, that's the ICS. That's why they're in business. Generally, that's less segmented off when you get inside of that blue area. Whereas up in the IT side, enterprise has different segments sectioned off pretty well. That zone between the yellow and the blue, the green zone there, you can see the cannons at that point, and they're kind of pointing towards outside. They're protecting the blue zone at that perimeter. But when it comes to architecture, if an adversary makes it past those cannons, those defenses, and those firewalls between IT and ICS, or the ICS DMZ level 3.5 in Purdue, if the adversary gets into the blue, it's not a good day on legacy environments because there's historically less segmentation in the ICS environment. So this control, defensible architecture, must go beyond just having a cannons at the external edge. We must do segmentation internally into the control system, and that's where the defense capability comes in. We can then contain threats. We can then create pivot points, areas in the network to do a collection if we have more points of segmentation. The third, and this is by far, I mean, they're all great controls, don't get me wrong here, and they're all pivotal based on the threats. The third control is ICS network visibility and monitoring. That means any control system, oil and gas, food, beverage, whoever, if we don't have today these controls primarily focusing on network visibility, the ability to look at the network traffic inside the industrial control environment, if we don't have that capability, here's the things we can't achieve. We cannot achieve passive, safe vulnerability management. We could not achieve identification of the 70% of assets that are engineering focused. And in that case, we cannot achieve things like engineering troubleshooting, and we cannot achieve ICS incident response capabilities. So control 3 is pivotal to all of these 5 controls. And it just so happens these are generally in order. So incident response, tabletop, and plan, check. 2, do your network properly, architect it properly to make sure you can reduce the capability of lateral movement, check. Then and only then will you get the most value of the next control, visibility, and the last 2 as well. So I want to take a little bit more time focusing on this third control of the 5 critical controls because 82% of mature facilities are focusing effort on hiring people for these roles and getting ICS specific technologies for this role. Inside of a control system environment, we see here generally, let's start from the top actually. At the very top of the screen, we see level 5, level 4. We generally call that the business network, level 5, level 4. You can see that represented by IT here. Everything below that, on the right side of the screen, there is level 3.5, DMZ. That's the demilitarized zone between IT and ICS. Everything below level 3.5 here, that's why the ICS is in business. That's your industrial control system. So what does that mean when we talk about visibility? If we only capture traffic and inspect traffic in the IT side, we're limited. Definitely don't stop doing it for IT, but when it comes to ICS environments, we have little value protecting the ICS from there. Continue doing it though, because adversaries come in to ICS a lot of the times. So what we do is we want to go down further into the ICS environment. Once we go inside the control system, now we're protecting the environment from a lot of different types of threats. Targeted threats, application threats as an example, anything going in and out of level 3 or the ICS environment. So 46% of threats, as we talked about, come into the ICS from IT at level 3. Right there, there's where you see visibility being super useful. But it becomes even more valuable once you get visibility, looking at packet captures inside the ICS environment. Inside of here in level 2, as an example, you can now detect everything we talked about before. The misuse of operating control devices in Ukraine, as an example. PIPEDREAM targeted tactics and techniques and procedures. Manipulated control devices, manipulated commands, supply chain attacks, transient device risks, and so on. It just so happens this control, visibility, monitoring inside the control system provides tons of benefits from a security perspective, but simultaneously it also creates capabilities for engineering staff, meaning the engineering staff who operate all this environment, they can actually use this control to help troubleshoot their environment as well. Not only able to detect malicious activity, but again, troubleshoot a whole bunch of different engineering specific aspects. And again, as you see, going down further into the organization, further into the ICS environment, we have now the capability to detect early stages of threats. Now, you may be thinking, I keep saying the word detect, detect, detect. Generally, inside of an ICS environment, there is no tolerance for false positive. So you're correct in thinking, yes, detection is a priority. Because if we have a false positive and a security tool falsely flags something that is legitimate, like a safety process, and it blocks that, then the controls we've deployed in prevention mode actually impedes safety. So again, there's no tolerance generally inside of an ICS environment for false positives. Thus, the controls, even this control, should be passive. The architecture is a different matter. That is definitely not passive, but you see the idea. We want to prioritize the ability for things to flow rather than causing false positives. So the last of the two controls, just before we get into any questions that you have, is secure remote access. This is control number 4. Now, IT does secure remote access really, really well. In the ICS environment, there's areas for us to grow. Now, the good news is that there's definitely capabilities to easily transition to, I'll say, secure remote access. But I would not suggest that the engineers don't set up remote access properly. In many cases, what you see here with regards to the Oldsmar event, the VPN filter, attack on Ukraine, and so on and so forth, this was not necessarily a lack of interest or passion or movement or action from the engineering side. In many cases, what we see is some vendors, some integrators may have their own solution that they would set up for contractual agreements and arrangements to do remote access, and they might not just be up to best practice. So, from a remote access perspective, it's definitely something that we always gravitate towards evaluation of, making sure there's a proper remote access point or at least monitoring into control systems. Now, before getting way down into the weeds here, just at a high level, multi-factor authentication is utmost. Yes, unfortunately, there is some non-multi-factor authentication devices connected to the internet today. That's a problem, and adversaries know that and they target those. Beyond multi-factor authentication, though, is a jump box, just like you'd see in IT, except for this is located in the DMZ for ICS, level 3.5, meaning you can actually monitor that device and control the traffic primarily for remote access. And remote access is definitely something over the last couple of years that has increased. And so this is not going away. So it definitely remains on the top 5 ICS cybersecurity critical controls. The last but certainly not least, we're going to talk a little bit about risk-based vulnerability management. So what does that mean? Does that just mean patching? Because IT patches regularly, like clockwork, every 30 days, and they do an amazing job of that. But the risk surface in ICS, while there's more vulnerabilities in the ICS generally, the ability for the adversary to get in there is different than what the adversary can get access to in IT. And of course, we know they pivot from IT to ICS. So I'm not saying don't patch. I'm saying we need to have a risk-based approach. There's even a flow chart to help us with this. So ICS CERT has a patch evaluation process. So patching should definitely continue for the industrial control systems, but we know it's not at a frequency of every 30 days as quick as it is with IT. Now, IT patches primarily because of users, which means we have a ton of users. 100% of an organization is on the IT network that likely has access to email and the internet. There's where most of the threats come in from, most of the threats. So as a result of that, that's why we prioritize patching every 30 days like clockwork in IT. And we're not going to change that. Inside of ICS, we probably have 5%, not 100% like IT, 5% of those users are on the ICS. And we should not have email systems and direct internet access from the ICS environment. So that alone, those facts or best practices alone should reduce the nature of the need for patching. We still need to patch. So you can utilize, or organizations can utilize, this patch evaluation process, and it works really well. And there's some mandation as well to patch more often in ICS, which is also healthy. But generally, this control comes down to this. It's ICS patching versus what we'll call living off the land. Generally, when there's a vulnerability discovered in the ICS, the engineering team with the IT team, engineering must be part of this evaluation. Otherwise, it doesn't make sense. So, from the engineering side, we also need to consider the engineering impacts of downtime due to a patch deployment and any associated workarounds, always versus the potential for number one, an adversary to actually get access to the ICS. Number two, actually find a vulnerability. Three, exploit that vulnerability by testing, by pre-positioning exploitation code as an example, and successfully exploiting the code so the adversary achieves something that the ICS natively does not provide it. What I mean is this: more and more the trend is less exploitation of vulnerabilities and just misoperate a control system. Like we've seen, and this goes back to even 10 years ago and still remains today. If an adversary can get access to an industrial control environment, they can absolutely find a vulnerability, test the vulnerability in the exploit, find the code, pre-position the code, and then exploit that vulnerability. But they could also just get in there, if they can get in there, and just pretend to be an operator and turn off power. Pretend to be an operator and overpressurize a pipeline, generally. So there's this idea, and there's evidence to back this up for years now, of patching doesn't necessarily make your ICS 100% better. Definitely want to patch, we want to continue, but living off the land, abusing the control system against itself is definitely something that needs to be considered when patching approaches. Just so happens we've done analysis on this year over year over year, and it turns out that there's a number of, I'll say, errors in different types of vulnerabilities that are provided. There's only a small subsection of vulnerabilities that actually matter, that doesn't give the adversary something the ICS natively doesn't provide it. And it's roughly between 7 and 10% of ICS vulnerabilities. Those are the ones that matter first, so we need to prioritize those. So, and that's a whole other conversation. But generally, these are the top five ICS cybersecurity critical controls. Before we just quickly review all of those fives in one slide, and before we get to questions coming up real soon, is that I'm in the field and I teach these classes. So the question is well, in 515, how do we teach it? What is it involved? On screen right here is an engineering kit that we provide with to every student. They get to take the kit home for further training and development. But essentially, in this class, we're looking at the network, obtaining visibility that we just covered, identifying assets, seeing threats, and then responding to those threats. So, in short, this kit that you have here, we're hacking and defending that kit essentially through most of the class. So that's the idea. The other class that I teach, which I co-authored, which is 418, ICS Security Essentials for Leadership. That's how to manage risk at an ICS or OT level. So the people, the personnel, the skills, the types of technology to deploy, and how to prioritize those. You guessed it, based on things like the five critical controls and safety. And that's the objective. So from my perspective, we've covered a couple of case studies on Ukraine. We talked about PIPEDREAM, which is like a Swiss Army knife of threats for ICS that can impact ICS globally. And then we've talked about the five ICS cybersecurity critical controls. They have to be nuanced and tailored to the ICS environment, and they are. Number one, ICS incident response. Remember, with that tabletop with engineering and safety. Number two, a defensible architecture inside the control system. Number three is ICS network and visibility, and that's monitoring the industrial control systems. Now you might think, wait a second, number three sounds a lot like what we do in IT. But the caveat is if you take an intrusion detection system or prevention system from IT and put it in the control system and turn on detection mode only, so you're not causing any false positives, there's still a high chance that won't work because number three here has to be, quote, ICS aware. It must understand the protocols that we use inside the control systems, which you generally won't see on the IT side. So a couple of them, and they go on and on. There's 250 plus. Modbus TCP, Profinet, for example, Ethernet IP and SIP. There's a bunch more. And so those need to be, whatever technology you put in place for three has to be ICS aware. Number four is the remote access, secure remote access, multi-factor authentication, jump box level 3.5, and access control, as we do in IT, to different parts of the ICS. And this does vary per sector as well. And number five, key vulnerability, risk-based vulnerability management. Rather than patch every 30 days, there might be more risk in patching every 30 days versus the probability of an adversary getting into the ICS, exploiting something, and so on and so forth, as we talked about. So that's a recap of the five ICS cybersecurity critical controls. Woo! We got through all the content, didn't rush anything, I don't think, and now we have a little bit of time left for any questions that you have. So, in fact, I have a couple questions on this side that you guys have submitted prior to the session today, but I want to just check to see if there's any in the Q&A section as well. So, do you want to jump on, Ashley, or will I take a
Yeah.
look?
Yeah. So let me read you one that came through into the chat. So
Okay.
the pandemic seems to have pushed IT OT convergence quite significantly. What do you think about the ability to maintain OT systems remotely from an IT environment as opposed to the traditional setup from an O&M facility? The air gap essentially does not exist anymore. Do you see these risks as IT risks or OT risks?
That's a great question. There's really four questions in there. So first of
Yeah.
all, I would agree that the pandemic has definitely increased the need for remote access. And I think that remote access needs to be further managed. That's why it's one of the critical controls. When it comes to the air gap, I think you're right. And I think that we've lost the air gap for a long time, even before the pandemic. So from my perspective, multi-factor authentication level 3.5 must continue. When you talk about the who should look after it or who's the responsible owner of it, from my perspective, I look at organizations like this, and I came from IT, so I'm allowed to say these things. When an organization has an ICS or OT network, the purpose of that organization is maintain operations and safety for the ICS. Every other department in an organization that has ICS or OT, HR, finance, IT, they are all support functions for the organization that has ICS and OT. So ICS and OT is the business. So when it comes to who owns remote access, what I can tell you is that IT does remote access generally very, very well. You also asked about OEM. When they come in remotely into industrial control environments, they can come in from coffee shops, which we never trust. So I think it's a healthy collaboration from IT and the engineering staff to work together to make sure two things. Number one, any access into a control system. Anybody's coming from the IT network to the ICS, same risk profile as you would treat them coming from a coffee shop or the internet. So IT and ICS should work together with the vendors on the ICS side, in my opinion, to make sure that the remote access that the vendor provides meets the standards of IT and engineering. I keep bringing the vendor in or the OEM in because generally when IT and ICS work together to create remote access, it works really well. The, the challenge I see in the field is that OEMs come in or vendors come in and they might under SLA service level agreements and contracts have maintenance agreements to maintain certain aspects of the control system, and they might very well put in their own remote access. So to summarize, it definitely needs to be a healthy collaboration. Who owns the risk? I think it depends on how the organization is structured, but I think that overall the ICS is the business period full stop. The risky part about remote access is not knowing that there is OEMs or integrators providing or installing remote access that the engineers or even IT might not be aware of. Great question. That sounds like a whole other webcast, by the way.
All right, we've got another one that came through. In some ICS environments, you may have over 100 different system of systems with many different PLCs and workstations that span decades. The risk-based process sounds great, but do you have a resource to explain how to do that at scale?
So if we're talking about protecting legacy devices, I mean, yeah, we have Windows XP still in control systems. That doesn't necessarily mean that a pipeline is going to blow up. It doesn't necessarily mean that the power is going to go out. For example, in the Ukraine in 2015, I know that's 10 years ago, if that system that the adversary targeted, if that was 100% patched, it would have made no difference. So when it comes to patching or legacy devices, I think that we will continue to live with legacy devices for quite some time. It comes down to the compensating controls we can put in place. So basic firewalls around legacy Windows boxes, for example, all of those kinds of things. The other part of the question, as I understand it, is who understands those environments, those devices. We can't do any of this effectively without talking with engineers leading the way. If we go into like kicking a door of a substation, boom, I'm here from IT security and lock this puppy down. Like what happens then is that you go in with the approach that like I know IT security, which is awesome. We want that. But you don't know 70% of what makes the control system in ICS. So there's a healthy conversation that needs to happen where you have to earn the trust of engineers because they're going to tell you, and the answer to your question is they're going to tell you what system of systems, how they operate, how they've been targeted, if there's any remote access to them at all, et cetera, and if they should be passed or can they be passed. And that's how you can work together with engineering staff to put in mitigating controls when we can't patch Windows XP and Windows 7. I know it hurts. Trust me. Windows XP, when I've just seen a system a little while ago this year that had Windows XP in it, and we did compensated controls, and there was no way to come off of it. But again, if it was fully patched, in many cases, it might not make that much of a difference. I'm not saying don't patch. Great question. Great question.
All right. Another question is considering how segmented ICS is from the rest of the network, are more threats becoming semi-autonomous? How do you defend against intelligent malware?
Love it. Fantastic. Great question. So first of all, the ICS in some suboptimal organizations are less segmented than we want. And so we commonly see that transition point or pivot point between IT and ICS. And this is generally why. IT and ICS should never, but they do share Active Directory domain controllers. And as a result of that, that's how a pivot point can be possibly created and be utilized. When you talk about autonomous malware or ICS specific malware, for example, I'm not saying I'm not worried about ransomware. I'm not saying I'm not worried about malware. But what I'm saying is that there is more living off the land than what we see than malware. Malware is used traditionally as an access gateway or a way to access an environment. So back to your question, to discover these kinds of autonomous malware or advanced malware, the five critical controls, if there was one, definitely focus on architecture first. The next one would certainly be network visibility. So you can detect malware as it pivots through, and you can detect any pre-positioning of that malware. So network, network, network. Great, great question.
All right. One more. In your experience, what has been the most effective way to help an OT network move from reactive compliance into a proactive culture of security?
Great question. So generally from my experience, I don't consider engineering staff or engineering functions as reactive at all. In fact, that group generally in engineering, and I've done global incident response here, that group generally knows exactly how to do emergency response when it comes to engineering failure and safety. So you asked about how to turn it from proactive to reactive. No, reactive to proactive. Generally, my experience is that engineers are very proactive when it comes to safety and integrity. So if I was to change the culture or augment the culture that usually is very good and positive around safety, tie a threat that it's a cyber threat into safety, and then go in and say, let's understand and let's level set that a cyber threat can impact safety. Usually engineers may not know that. They know everything about safety, but they may not know and be aware of that safety can be impacted by cyber. So it starts with a conversation, coffee and donuts with engineers and earn their trust and then have a conversation about how do we proactively get ahead of cyber aspects? How do we leverage the safety culture to install the five critical controls, for example, to reduce the impacts of safety from a cyber event? Great question.
All right. And we've got another one that came through. Are there any vendors out there coming out with newer systems, hardware, software, et cetera, to help protect and segment ICS and OT systems?
Of course. So there's actually a number of vendors, ICS specific vendors, who are protocol aware. There are data diodes or unidirectional gateways, as an example, when you talked about segmentation, that only allow outbound communications from the ICS. A lot of the threats we see in the control system come in from IT 46% of the time. So these ICS specific firewalls, industrial grade firewalls, or with proper access control lists, or data diodes only allow outbound communication. So regardless if it attempts to do a TCP communication connection, it's not going to be able to maintain a handshake that allows bidirectional traffic. So to answer your question, yes, there are several from a firewall perspective, architecture perspective, as well as a network visibility perspective? Great question.
All right, those are ones that came through live. So if you want to answer some of the ones that were pre-submitted, go for
Yeah,
that.
for sure. Okay. This is awesome. You guys have been super great. Another question here that's we have is, do you expect penetration testing and vulnerability assessments to gain traction in the OT or ICS network space? 100%. So I've been doing assessments and penetration tests for quite some time, but there are nuances to this as well because a pen test in IT doesn't necessarily tip things over. In an ICS environment, a pen test absolutely has high impact and high probability to cause problems. So organizations that come to me, usually in the field in oil and gas, water, wastewater, electric, they actually ask me, yeah, we need to do an annual penetration test, but this year we want to do it on ICS. So can you help us do a pen test? Usually when I go in and say, here's what we can do, here's what the problems are you sure you want to proceed? And they're like, wait a second, like a pen test is actively exploiting something? Wait a second, a pen test can actually turn off a PLC? Like that's bad. And so usually the conversation turns into we wanted a pen test, but we realized the risk a penetration test can bring to an ICS if not done properly. And we prefer a pen test only in this part of the network in a controlled environment or a passive vulnerability assessment. In saying that, SANS ICS 613 is now in beta, coming out in beta really soon, like actually this week, next week. And that is an ICS penetration testing class. And in that class, we're going to teach how to do penetration testing in a safe way. So it's not just let's go do, Nessus Nmap scans or like, Christmas tree scan attacks across the network, those kinds of things. It shows you how to properly do assessments in ICS, properly, safely do penetration tests and so on. Great, great question. Do we have any question or time for one more? What do you think, Ashley?
Absolutely, go for it.
Okay. What are the ways for someone to transition from IT into ICS? So by and large, this is how I did it, and this is the most effective from my experience. If you're in an organization today that has ICS, the quickest, less painful, lowest cost way to do this is job shadow an engineer. And I'm talking like work with the engineer at site for like 2 or 3 or 4 months. If you can make that happen within your work environment, then you're well ahead of the game. Aside from taking our classes, obviously, but if you get experience with engineers in the field, you will probably leapfrog your career by years, by 2 or 3 months working with engineers, without question. Great question on that.
We actually
Um,
one more just come through. Um,
okay,
this person, they met you in Chicago last summer, and then you
awesome.
mentioned that a course was coming up with cloud and ICS. Is that in the works?
That's awesome, dude. Chicago, like I can't wait to get back there. Good to connect with you again. It is in the works, but the ICS penetration testing class is coming out first. However, having said that, we absolutely have content coming up very soon within the next 2 weeks on ICS and cloud. In fact, we have a blog series that's in development right now, so stay tuned on that. You can actually reach out to me on LinkedIn with the link on screen, and I'll be releasing that probably within the next 2 weeks. So hopefully that helps you out and gets us a little bit further along the way to that course.
Awesome. I think that is it, unless anyone else has any last questions. No?
Awesome.
Okay. Also, I do want to say that there is an ICS Security Summit and Training happening in Florida in June. And so you can take ICS classes in person. I know the ICS team loves to see folks in person, right, Dean?
Yeah, so actually, a really good point on that is that this is the 20th anniversary of the ICS Summit, and it's not just classes because we have hands-on workshops. So if you want to get your hands on gear, we're loading up like I think it's like 75 PLCs at the front of the room. We have ways to hack and defend it the entire 2 days or 3 days of the summit. 310, which is the foundations, is going to be available there. I think free for anybody attending the conference as well. There's talks, but the majority of the content is hands-on workshops. I'm going to be there doing the solutions track. I'll also be doing an instant response demonstration on screen as well, interactive with the class, which will also be pivoting to a tabletop. Yeah, tons of cool things happening, but practical field experience as well. So yeah, Ashley, totally right on that. I'm definitely going to be nailing that. I'm going to be there. It's going to be great.
Yeah, I put the link in the chat for you guys so you can learn more about the summit. And if you do have questions about attending it, we'll take a course there, talk to your advisor. And you guys can work with your advisor to get registered for attending the summit if you want to do that. But that is all for us today. I do want to say, I know I mentioned in my email that we are raffling off a copy of Dean's book. And I did take attendance in the middle of the presentation, and our winner was Jewel. And so I want to say congratulations to Jewel Hamlin. You are the winner. So we will be in touch with Jewel later about how to get that book to her. So yay, congratulations. Thank you
Awesome.
so much, everyone, for coming. We really hope you enjoyed this today. And we will hopefully get to do more of these in the future.
Awesome. Thank you so much, Ashley, for having me. Thanks everybody for having me as well. Have a great day. Thanks again. Talk to you soon.
Thanks, everyone. Have a great rest of your day.